You have spent your entire life assuming Earth has one companion in space, the Moon. You are wrong. Right now, a second object is riding along beside our planet. One small enough to hide from almost every telescope on Earth, and old enough to have been doing this for centuries. For as long as humans have looked up, we assumed we knew our own neighborhood. One planet, one moon. A simple picture. That picture was never complete, and the object that broke it was hiding in plain sight the entire time, close enough to photograph if anyone had known where to look.
Its name is Kamo'oalewa. In Hawaiian, that means the oscillating fragment, a name pulled from an ancient creation chant describing something that moves with the sky. Astronomers first spotted it in April of 2016, using a survey telescope on a volcano in Hawaii called Pan-STARRS. That telescope was not even built to hunt for hidden companions. It exists to scan the sky for objects that could one day threaten Earth, a planetary defense system essentially. Kamo'oalewa turned up almost by accident, caught in the same nightly sweep meant to catch something far more dangerous. At first glance, it looked like just another passing space rock. It wasn't. Kamo'oalewa turned out to be something astronomers call a quasi-satellite. That is not the same thing as a moon. The real moon is locked to Earth by gravity. It orbits us directly, and it always has. Kamo'oalewa does something stranger. It orbits the sun on almost exactly the same one-year schedule as Earth does. Because the two paths are so closely matched, our planet's gravity nudges it just enough to keep it trailing nearby without ever fully capturing it. From Earth's point of view, it looks like a second moon. From the sun's point of view, it's just another rock, quietly matching our pace. Ground-based telescopes estimated Kamo'oalewa to be somewhere between 40 and 100 meters wide, roughly the size of a small building, and it spins fast. One full rotation takes about 28 minutes. For comparison, the moon takes nearly a month to rotate once. Here is where it gets uncomfortable. Orbital dynamicists have run Kamo'oalewa's path backward through time, trying to figure out how long it has actually been keeping pace with Earth. The models do not fully agree. Some calculations suggest it settled into this Earth-linked orbit around a century ago. Other analyses push that number back further toward 400 or 500 years. Either way, the conclusion is the same. This rock has been shadowing our planet since long before any human had the instruments to notice. It is also extraordinarily faint, by some estimates around 4 million times dimmer than the faintest star you can see with your naked eye. That is the real reason it stayed hidden. Not because it was far away, because it was too small, too dark, and too quiet for anything except a modern survey telescope to catch. Astronomers have since identified a small family of these Earth-trailing companions. Estimates range from 5 to 8 known objects, depending on how strictly their orbits qualify. Kamo'oalewa is the most stable of them all, but the orbit was never the biggest question. The bigger question is what Kamo'oalewa is actually made of and where it came from. In 2021, researchers using 2 large telescopes in Arizona pointed them at Kamo'oalewa and measured how it reflects light. The spectrum came back looking strange, reddened, weathered, and eerily similar to lunar rock samples brought back by the Apollo 14 astronauts. That single data point cracked the case wide open. If the comparison held, Kamo'oalewa was not an ordinary asteroid at all. It might be a literal piece of the moon. By 2024, a team of researchers had gone further, running impact simulations to figure out exactly where on the lunar surface such a fragment could have come from. The software they used for that reconstruction has an odd history of its own. The same type of code originally built decades ago to model high-speed explosive impacts, repurposed here to model a rock breaking off the moon instead. Their conclusion pointed to Giordano Bruno, a large crater on the moon's far side, created by an impact somewhere between 1 million and 10 million years ago. An impact violent enough to launch debris clear off the lunar surface and into orbit around the sun. Other researchers, running the same kind of analysis, have pointed instead to a different older crater called Tycho. And more recent observations, including data from the James Webb Space Telescope, have pushed back on the entire moon fragment idea, suggesting Kamo'oalewa might instead be an unusual type of ordinary asteroid, heavily altered by exposure to space. So, right now, nobody actually knows for certain. 3 competing explanations. 0 confirmed answers, which is exactly why China decided to go get a piece of it. The mission is called Tianwen-2, and it launched from southern China in May of 2025. For the next 400 days, the spacecraft crossed roughly 620 million miles of space, more than 1 billion kilometers, just to reach a rock the size of a school bus. China's space agency stayed almost completely silent the entire time. No countdown, no updates. It was amateur radio trackers in Europe who first picked up signs that the spacecraft was maneuvering near its target, weeks before any official statement. Then, in early July of 2026, the silence broke. China's space agency released the first close-up photograph of Kamo'oalewa ever taken, captured from a distance of about 20 kilometers. a little over 12 miles. The image showed a small, lopsided, rocky body, not round, not smooth, and rotating so fast that photographing it clearly is its own technical challenge. The spacecraft carries 11 separate science instruments: cameras, spectrometers, radar, a magnetometer, even a dust analyzer contributed by Italian researchers.
Tianwen-2 is not just there to take pictures. Over the following months, it will creep closer. First to under 2 miles, then 600 meters, then just 300 meters from the surface, mapping every visible feature before attempting to touch it. Because nobody knows exactly what the surface is made of, the spacecraft carries 3 completely different sampling methods. It can hover just above the surface and vacuum up loose particles. It can perform a brief touch and go, firing a burst of gas to kick material upward and catch it on the way back down. Or, if the terrain allows, it can anchor directly onto the asteroid and drill into the subsurface. The goal is to bring home somewhere between 20 and 100 milligrams of material. That is a few grains of rock, and it may be enough to finally end a 5-year scientific argument. If Tianwen-Hells not 2 succeeds, China becomes only the 3rd nation in history to bring asteroid material back to Earth. Japan managed it first, returning samples from the asteroid Itokawa and later from Ayugu. The United States followed, hauling material back from the asteroid Bennu. Both of those missions rewrote textbooks, revealing amino acids, the building blocks of life, embedded inside ordinary space rock. Nobody yet knows what Kamo'oalewa will reveal. If the sample matches lunar material, Kamo'oalewa becomes something almost unheard of, a confirmed piece of the moon, independently orbiting the sun that humans lived beside for generations without knowing it existed. If it does not match, it becomes proof that ordinary asteroids can be captured into Earth's orbital neighborhood far more easily than anyone assumed. Which means there could be more of them out there right now, still unseen. Tianwen-2 is expected to leave Kamo'oalewa in April of 2027, dropping its sample capsule into Earth's atmosphere later that same year. After that, it will keep going toward a comet out past the asteroid belt, making it the first spacecraft in history to study both an asteroid and a comet on a single mission. But the real story here is not really about the spacecraft. It's about what it took to even find Kamo'oalewa in the first place. A rock roughly the size of a school bus, spinning once every 28 minutes, riding along beside Earth for a century or more. Completely undetected, because nothing was looking closely enough. That is the uncomfortable part. It is not that space is empty and Earth is alone in it. It is that space right next to us has never been as empty as we assumed. We simply were not equipped to see what was already there. So, the next time you look up and see the moon, remember that it might not be the only thing up there keeping pace with you. Something smaller has been doing the exact same thing, quietly, patiently, for longer than anyone alive has been watching the sky. And until 2016, nobody on Earth had any idea it was there. The real question now is, what else might still be out there, close enough to matter, and still small enough to hide?